with a new video. One of the most important topic of inorganic chemistry. Today I will just simplify the topic. If you haven't subscribed my channel, please do subscribe because I keep on uploading video on various topics which will help you a lot. You can find videos on topics like polymers, hydrogen, environmental chemistry above in the I button or in description box. I'm sure that these tables might have puzzled you and made feel sick of inorganic chemistry. But stop now, because today this sickness will become a history. I am here to make things simpler and easier. So before I begin, just subscribe the channel, like the video and share with your friends so that they can get these useful contents to prepare for their exam. Without wasting time, let's begin with some major concepts. We will cover three main topics: variation of size, variation of ionization energy, electron gain enthalpy. First topic will deal with effective nuclear charge and shell number. So these two factors will affect variation of size, variation of ionization energy. Factors such as nuclear charge, shell number and completely or half-filled rule decide the variation of ionization energy. Effective nuclear charge, shell number, completely or half-filled rule and penetration power plays vital role in deciding electron gain enthalpy variation of various elements. So big question arises, what is effective nuclear charge? To understand this, we should know that electron experiences two types of forces around nucleus: force of attraction of nucleus, repulsion due to presence of middle electron. So electron will experience a force of attraction as well as repulsion. Now, what is screening or shielding effect? Ability of middle electron to repel outer electron is known as screening effect. So middle electron will repel outermost electron, and this effect is known as shielding effect. Due to repulsion, net force of attraction decreases on the electron. So we can say Z effective, also called effective nuclear charge, is Z minus screening coefficient. We can calculate screening coefficient, but I will not discuss that in this video. If you want, you can tell me in comment box, I can make different video. So with the help of that, you can calculate Z effective. It is very important. It plays important role in deciding various properties. So greater shielding power, lesser will be effective nuclear charge. You can just consider shielding power as a barrier. If this barrier is more, there will be less force on outermost electron, hence effective nuclear charge will be less. And if effective nuclear charge is less, definitely electron will experience less force. So we will begin with this first topic, which is electronegativity. It is the tendency to attract shared pair of electron. This data is actually very important, mentioned in NCERT book. Table I had shown you, it was mentioned in that also. So it is better to remember some points, some data from this, how much you can remember. It will be beneficial. You can see here that fluorine is most electronegative. Means fluorine has more tendency to attract shared pair of electrons. Now we will move on. Another important point, atomic size. We will see how size varies in S, P, D block along the group and along the period. Here you can see in general, as we go down the group, whether it is S block or it is P block, size will increase due to down the group size increases due to increase in shell number. Shell number will increase, so there will be less force of attraction on outermost electron, hence size will increase. But there is one exception which is mentioned in one of the chapters of NCERT book. This is mentioned in NCERT that atomic radii of gallium is less than that of aluminium. So what you will do, you will just make this order that thallium has highest atomic size, then indium, then not gallium. Aluminium will come downward. This arrow is indicating that this will come down. It is a way better way to remember this. You need to do what? You will say in general this is the trend. But you will keep in mind there is one exception that this will come here. So this statement is exactly mentioned in NCERT book of P block class 11th that atomic radii of gallium is less than that of aluminium. So in general size increases downside, but this is one of the exceptions. Now we will talk about along the period. So you can read here that along the period size decreases because if you will think of shell number, it remains constant, it will not change, but effective nuclear charge increases, means more force of attraction on the electron, means size will decrease. So in general size decreases in this manner, but after mentioning this you will keep in mind that neon is the largest element, so it will come at the first position. Similarly, all the noble gases like argon, this will also come at the first position. So when we talk about atomic size, we will see some questions also based on this which has been asked. Only two things you have to keep in mind whenever this question will be asked. Just keep two things in mind, that size increases down the group with one exception. Size decreases along the period with one exception. An exception you will keep in mind, and you will always remember the things in this manner that size will decrease but neon will come at the first position. In boron family, size will increase down the group, but aluminium will come here, means aluminium is having larger atomic size than gallium. Then definitely you will do correct in exam. Now we will talk about D block. When you will read class 12th D block chapter, you will find these all. Similarly, in previous part whatever I have shown, it is from class 12th as well as class 11. So we are covering entire topic which is required for exam. An exam, it can be asked from anywhere. So if you are in class 11th, you should consider these points as very important because you have to appear in an exam. Now This is the general trend in along the period of D block, like scandium, titanium, vanadium, chromium, manganese, till this size is decreasing. But manganese, iron, cobalt, nickel have almost same atomic size, and after that there is increase in size from nickel, copper, zinc. This is the chart of NCERT D block class 12th, which is depicting almost similar thing. It is not showing equal size here. You can see like it is decreasing, then almost constant, then increasing. That I have shown here. It is almost same radii here. Now along the group 3D, 4D, 5D series. So here you can see as we go down, size will increase, but after that there is constant size. Even you will find one question, I will show you later on. One question has been framed from this part. So you need to keep this in mind, that if I talk from here to here, titanium to zinc, titanium, zirconium, hafnium, sizes firstly increasing, then constant. Similarly here, zinc, cadmium, mercury, same trend is there. Only here you will see that scandium, yttrium, lanthanum and actinium has almost same atomic size. Now we will talk about ionization energy or ionization potential. So what it is? Minimum energy required to remove electron from valence shell taken to infinity is called ionization energy. So this is also very important point. Some important point I have mentioned here, like cationic size. So this is very simple concept. If I remove one electron from sodium, so it will become sodium plus. So when it becomes sodium plus, there is one electron less in sodium now. What nucleus will do? Nucleus has seen that one electron has gone. So it will pay more attention on left electrons. So more attention means more force. More force means size will decrease. So if I say which is larger, sodium atom or sodium plus ion, definitely sodium atom will have large atomic size than sodium plus. This is a way to keep in mind. Similarly in chlorine minus, there is one more electron. Now nucleus will apply force but little less. Why? Because number has increased. It is difficult for nucleus to pay more attention to each electron. When electron was reduced, it was carefully applying force. But now number has increased. We know that if there is large number of people, it will be difficult to manage things. If persons are less, then we can manage them carefully. In similar manner, you can keep these facts in mind, that when electron is removed from sodium, more force of attraction means size will decrease. In case of an ion, chlorine gets one more electron, little difficulty, so size will increase because less force of attraction means less Z effective. Now for isoelectronic species, this is one of the favorite questions of JEE mains, which is inversely proportional to Z, means more Z if electrons are same in all the elements. More Z means less size. Now again, ionization energy depends on effective nuclear charge, shell number, complete or half filled rule. This is very important, complete or half filled rule. You will see now, then you will understand why it is important. So many questions has been framed from this part. Now we will talk about ionization potential. First ionization potential for S and P block along the period and along the group. So for first ionization potential, along the period ionization energy increases due to increase in Z effective. I had told you that Z effective increases along the period. Now more Z effective means more difficulty in removing the electron. So more energy is required. So ionization energy will increase. We have to provide more energy, then we can take out the electron. So if you will see this, definitely this will have more ionization energy. What about this? General concept says that neon will have highest ionization energy since it has more Z effective fluorine, oxygen, nitrogen. Means along the period we are going, ionization energy will increase due to increase in Z effective. But one more fact plays an important role, which is completely filled and half filled orbitals. So there are some points and which is asked in almost every paper. Just say in a particular JEE mains there are 7 to 8 papers in different shift. Definitely you will find 2-3 shift in which question has been asked from this part. So you can understand how much important this is. What is the thing? It is that berylium will come ahead of boron. Why? Because berylium, if you write electronic configuration, it is 1s2 2s2, means it has a completely filled s orbital. Completely filled and half filled rule is that if there is completely filled or half filled atom, orbital is there in an atom, then it will have more ionization energy. That's why this will come ahead. It will have more ionization energy than boron. Similarly, nitrogen is half filled, so it will come ahead of oxygen. You know that it is 2s2 2p3. So 2p3 means 3 in p orbital, means half filled. So it will be ahead of oxygen. Similarly, for sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, the order will be again in the same manner. So what you have to keep in mind, that ionization energy will increase along the period, but take care of half filled and completely filled rule. For second ionization potential, I will not say anything because it is simple. You have to remove one electron, and definitely along the period again, due to increase in Z effective, ionization energy will increase, but take care of what? Take care of completely filled and half filled rule. Like lithium is now completely filled, so it will come ahead. Similarly, these all you can check this. Same concept. So in this manner we can tell first and second ionization potential. Now what about along the group? This is mentioned in NCERT. As you can see, let me tell, along the group ionization energy decrease due to increase in shell number. You can imagine this. As soon as cell number will increase, less force of attraction, means electron can be removed easily, means ionization energy will decrease. So what general concept says is it should decrease, but what NCERT is saying, see, this is periodic properties. which is different chapter, and what I have picked here is from some other chapter like P block, S block, D block. But why I have picked? Because it is demand of paper of JEE Mains or JEE Advanced. If you have to do well, you have to study in this way, because questions are framed every year. Almost every shift has some part from it. It is very important for your understanding of inorganic chemistry. If you will not understand this, definitely inorganic chemistry will be a problem for you. So you should recognize what is the right way and what is the right resource to study. So the ionization enthalpy values as expected from the general trend do not decrease smoothly down the group. It is saying that it is talking about a boron family. You can find this paragraph in P block class 11th. So what it is saying that it is not very smooth decrease in ionization enthalpy along the group, but there is some changes. What are those? First change, that aluminum has less ionization energy than gallium, and even it has mentioned some point here, the observed discontinuity in ionization enthalpy values between aluminum and gallium, which I have mentioned here. Even you can find exact data of ionization energies in the table of P block of class 11th and 12th. You know, P block of class 12th is really long chapter, but I think if you will understand these points, a lot of problem will be solved. Because if you will read class 12th P block chapter, in the starting part of it, you will find many points which I will cover in this video, and even later I will make. If you want to give some suggestions, you can mention in the comment box. It will help me a lot. And if you like it is good content, definitely like the video. It will promote me. It will keep me enthusiastic to make further videos. So aluminum will come below. There are some other points also, that thallium will come above indium, and last change, that lead will have more ionization energy than tin. So this you have to keep in mind. Definitely this is much easier. I will say much easier, because more easy than this can't be made. To read this para is easy, or to read this from here and connect it that it is mentioned in NCERT and then keep it in mind is easier. Tell me in comment box. I think for me it was much easier to read from this table and then connect that, oh, this is mentioned in NCERT, but I know in very simpler way, it is in my mind. I have to not keep these points like a story in mind. I will just say that I know shell will increase, so ionization enthalpies will decrease, but there are 3 points which I have to keep in mind, that aluminum will come here, thallium will come here, lead will come here. Done. I have to not keep all this para and a big burden on my head. I think everyone will agree with this point. So let me know in comment box. Now for D block, simple. As soon as we will move from here to here, scandium to zinc, ionization energy will increase. Now for along the group, there are 2 exceptions and some important points. You can see here that 3D series has more ionization than 4D and 5D has more than 4D, which I had shown here, like titanium, zirconium, hafnium. copper, silver, gold, zinc, cadmium, mercury, same trend is there. But what you have to keep in mind is nickel, palladium, platinum has just opposite. Means nickel, palladium, platinum has highest ionization energy, continuously decreasing. And scandium, yttrium, lanthanum decreasing, then actinium increasing. It is similar to this one. Like since here one more element is there, so it was like here decreasing, then at the end increasing. Same thing is here, decreasing, then increasing. These all data you will find in D block. Somebody from class 12, if seeing this video, might be knowing that D block a very good chapter, and many people leave that chapter. But if you keep these points in mind, definitely some part will be covered and your burden will lessen. Same is for P block. P block of class 12 is little bit long, but if you keep these points and then you study that chapter, a large part of your burden will lessen. This I am saying because I felt that during my preparation. So you should follow this, and I think if you have not subscribed my channel till now, I don't know why you are doing that. Should like and subscribe at this point. Pause the video and like and subscribe my video. Now, electron affinity, electron gain enthalpy. Very important point. Again, many questions has been asked from this, and definitely P block, S block, D block, and every topic of inorganic related to periodic table, you will find some points related to it in every table of NCERT, which I will cover here. So what is electron affinity? Tendency to attract electron. Electron gain enthalpy. Enthalpy change when an electron is added to valence shell of an isolated gaseous atom. Now important point is that if electron affinity is positive, then electron gain enthalpy will be negative. What does this mean? This means that if an element atom want to get electron, attracts electron, then there will be release of energy in that process. So energy will release, and you are knowing whenever energy is released, it is always taken as negative. So this is a positive indication that electron, whenever it is said that electron gain enthalpy is negative, means that element has the tendency to accept electron. And if it EGE, electron gain enthalpy, is positive, like these elements of periodic table have electron gain enthalpy positive, this will help you a lot. So keep in mind. Beryllium, magnesium, calcium, strontium, barium, radium, and here helium, neon, argon, krypton, xenon, radon. All these elements and nitrogen have electron gain enthalpy positive. Means they don't want to accept electron. Even you are knowing that noble gases, they are noble in nature. They don't react easily. They don't accept electron. They don't want to attract electron, or they don't want to get electron. Definitely they will have positive. But for these elements, you have to keep in mind. This will help you a lot. Now you can see here, very important point we are going to cover now. Generally for along the group, going downside will decrease electron gain enthalpy. Means as soon as we go downward, there is less tendency to accept electron. But there are some exceptions which has been asked frequently. First, electron affinity of second period element is less than that of third period element due to introduction of d orbital in third period. This is third period, and here d block is introduced, d orbital is introduced, due to which these elements have more electron affinity, so they will come above. They will come above means generally what will you do? You will decrease electron affinity, but you will send these elements of third period in second. But there is one more exception for oxygen family, that oxygen will come at the lowest most position. This is very important. Two exceptions are there in oxygen family, and this has been asked in many exams, not once, twice, thrice it has been asked. So this is very important, and keeping this manner, this will summarize the entire topic and will help you a lot. You are knowing if question is from atomic size, you will recall that these were the points and this was the exception. From electron gain enthalpy along the group, along the period, these were the points and this was the exception. And even you are seeing this video and you are seeing these arrows, this will have great impact on your brain. You will have some part of this image always in your brain, that this was going there and that was coming here. That's why I made this video in this manner. Now, along the period, if we talk about, so one thing more you can observe that chlorine has highest electron affinity in the periodic table. Since this has come above, means fluorine has gone down. So chlorine has the highest. In two ways you can understand. When we go along the period, electron affinity increases. You can better understand that these elements, means oxygen, fluorine, these elements have more tendency to accept electron. So definitely when we go along the period, electron affinity increases. So from when we come from here to here, electron affinity will increase, and from here to here also electron affinity increase. So this topmost element, chlorine, when it will come here, it will be most electron affinity element. Now along the period there is some other exceptions. Neon, definitely neon is noble gas, it will come at the last. Nitrogen will come here. Tell me in comment box why nitrogen will come here. Pause the video, think over it, tell me in the comment box. This is just to test you whether you are listening the video carefully or not. If not listening, then pause the video, go 5 to 10 minutes back, listen again, come here and then try to answer this question: why the electron affinity of nitrogen is very less than carbon, boron and these elements? Why? Answer in comment box. That don't leave. Answer it, whether it is correct or not. If you are getting some logic, then mention it. I will check that, and then you will play the video and you will see what I am telling. Just don't ignore this, take it very seriously, it will help you definitely. Now I am telling why this is coming here. I showed some elements which had electron affinity positive. Among them was nitrogen, and similarly beryllium. I had also shown you beryllium. So since they have electron affinity positive, means they have less tendency to accept electron, and other element have negative electron affinity, so positive one will come back because they have less tendency to accept electrons. So if you are able to answer, then it is good, but if you are not able, definitely you should listen the video carefully, and whenever I say answer in comment box, you should, because it will help you. I'm saying for your benefit. Answering the questions will keep you activated, so always follow this. You should follow it. So this is the final order. Now we will begin with first question. Again I will say these are completely based on what I told till now. You should pause the video and answer, like you can mention in the comment box answer of question 1, 2, 3, 4, 5, like this. Pause the video. Now I will tell the answer. It is first. Now let me tell one more important point. So we have to tell increasing order of first ionization enthalpy. You will see, you will recognize, yes, magnesium is there, aluminum means magnesium, aluminum, silicon, phosphorus, sulfur. We have to compare them. Ionization enthalpy is there. I told you an important point. You will recognize where I was ionization energy along the period. Yes, there were some exceptions. Definitely it will be there somewhere. You will do mistake, you will get negative marks. Definitely option will be there for negative marks. So magnesium, aluminum, definitely magnesium will come ahead. Why? Because it is completely filled. So third and fourth option cannot be. I will focus on first and second. Now magnesium, aluminum, silicon, phosphorus, sulfur. So phosphorus is half filled orbital, so it will come in ahead of sulfur. So definitely first option will be correct. Next question, pause the video, answer it, mention question 2, answer, option number, and then play the video. Now I will show the answer. Answer is first. If you have your answer was correct, you can mention my answer was correct. So it is not difficult question, it is simple one, and again same concept of ionization energy. You can recognize two questions till now we have seen of ionization. There are infinite number of questions, so you have to understand the concept, then after that it will be easy task. So again it is based on same concept of half filled and completely filled rule. I will not tell anything, because if you want to just if you have any confusion, you should see the part of ionization energy again. The correct order of electron gain enthalpy is again from same part. Answer it, pause the video. Now I will tell the answer. Answer is first. So for electron gain enthalpy along the period, I told you that you have to take some care. We are talking about electron gain enthalpy along the group. So I told you that one of the very important oxygen family, and I even told that there are two exceptions in this. So oxygen will come at the last, means either first can be correct or fourth can be correct, and definitely sulfur of third period will come at the first position. So first is correct. Moving on next. In comparison to boron, berylium has. Pause the video, answer it. Now I will tell the answer. Answer is first that beryllium has lesser nuclear charge. Yes, it is correct, because when we move along the period, nuclear charge will increase, means beryllium, then boron means beryllium has less nuclear charge. and greater first ionization energy. Again, from the exception of part, beryllium is completely filled, so it will come ahead of boron. Now moving on, next question. The first electron gain enthalpy of oxygen is minus 141 kilojoule per mole. Its second electron gain enthalpy is. So again, simple question. You have to think a little and you can answer it in comment box. Pause the video, answer this question in comment box, then play the video. Take it very seriously. Now I will show the answer. It is third, a positive value. It is very correct because when you will remove one electron, the nucleus will exert more force. So it will be difficult to take out the next electron. So we need to supply energy, means delta H will be positive now. Almost the same as that of first, not at all negative but less negative than first, a more negative value than first. Definitely these are not correct. A positive value is correct because taking out second electron is not easier. And for more detail you can read NCERT book. You will more understand, you will find even data, exact data. It is up to you. But firstly you should understand all the major concepts which I told in the starting part of the video. If you have any confusion, you can just go back and listen that part, but keep those points in mind. And if you have not learned periodic table, group wise means you should learn group wise means scandium, titanium, vanadium. This you are knowing, might have learned during class 10th time. But now you should learn scandium, yttrium, lanthanum, actinium in this manner. Group wise, boron family, then oxygen family. This will help you because questions are framed in that manner. Now you have to answer some questions in comment box, which will be homework for you. When I say answer in comment box, please do not ignore that. It is for your benefit. If you will not answer, definitely you will not get that much profit as you should get. So question number 6 is the atomic radii of silver is closest to. I have discussed somewhere back. The correct order of electron gain enthalpy of fluorine, chlorine, bromine, iodine. Again, electron gain enthalpy I have discussed. It is based on that. Only data is given to just make you a little worried if you get worried very fast. And next question is the ionic radii of N-3, O-2, F- respectively. So this also I discussed. It is ionic radii. Always take care that. First question was electron gain enthalpy. Yes, I read somewhere there. Atomic radii. This also I read. Atomic size. Ionic size. Yes, that also I discussed. Go back and watch the video. It's all right. So with this we will end this video. Like the video, subscribe the channel, share with your friends, and you can also get the link of the website where you can find quiz